Hey, welcome back to our channel. So let's do some maths here. This is a question related to kinematics. So let's do it. So we have a function of velocity, and they want to find the velocity when t equals to 2. So pretty straightforward. We are looking for v2 there. So all you need to do is key that in the calculator. We are doing calculus here, and the sign. The number is like pretty small, not by hundreds. So make sure your calculator is in radian mode. So let's do it. So 1 plus e to the power -2 minus e to the power negative sine 2 times 2 is 4. So we got the answer here negative. When it's negative, it's going backwards, right? So 3 significant figures. So the answer is negative 0.996. If you want, you can have amperes for it. So B, find the maximum velocity means that we have to differentiate t equals to 0. And I'm not going to do that. I'm going to use my calculator to help me to do it. So remove the old equation, or you can just get to the new one. So I will have 1 plus e to the power -2. Feel free to differentiate it, but I am just, because some of you might be doing it even quicker than I do. So, but I'll just leave it for now. So I got the function here. It should draw like this. Yeah. And then I put it into the correct domain. So it's like 0 to t. Okay, and then what I'm going to do is I will have the differentiation. So option, actually I want to show off the skills. Option cal dy dx. All you need to do is put the function in, and they will differentiate for you. Takes a bit of the time. And we want to find out g solve equals to 0, so it's actually the root of the second equation. Woo! We got the answer here. Don't even need the working with those. So we will have t will be equal to 0.40583, but we want the velocity. So we need to find out then. So we need to substitute back this into the equation, which I am not going to do it. I'm going to do g-solve as well. So I will remember a few digits here. So I will have to g-solve. I want y-cal for the first equation, and then 0.40583. And I should get the value here of the blue function. Looks the same. So this is our velocity when the velocity is at max. The time at the max, this is the highest velocity. So I'm going to write that down. Equals to 361.18 as our answer, amperes. Okay, so our calculator is so cool here. I want to find the acceleration of the particle which have the instant change. So to do that, you have to recognize that when you don't have to write this, but I just write it out for us to understand. When the direction change, Vt should be equals to 0 because it go back to the correct. If it stop moving forward and start moving backwards. So we need to find out that. So we need to solve it. So g solve root of the blue one, the velocity. This gives us 1.65. So v at that time, t should be equal to 1.658. It's not the final answer, so I write a few more digits there. And then I need to find out where a is. So I have to g-solve again. But this time, and this is again y-cal, but this time I'm looking for the second one, the differentiator function. Okay, g-solve, the y-cal, I'm looking for the second one. So I'm going to draw that, and I'll write down this value here. So 1.6584063. Remember, if it's a GDC paper, do not, I would not suggest you to do all the math there because it doesn't worth the time. Again, 366, so it's 0.53, negative 0.53. m per s squared. All right. How did you do? Did you do it by hand or did you do it with a calculator? Let us know how you feel in the comment. And until next time.